We're going to get started in a minute here. I'd like to introduce Martin Mallow, who's the CTO of SES. He's going to be your featured speaker today. If you have any questions for him after he gives his opening remarks, feel free to ask. John Taylor and I will be around after the briefing if you have any questions about the SpaceX. But our focus for this briefing is really SES-9 and the upcoming mission. We're going to keep the conversation in. With that, I'll turn it over to Martin. Go ahead and get started.
Thanks, Emily. Don't go too far away.
I'll stay right here.
Okay. In case of any tricky rocket questions. Okay, can you guys all hear me at the back? Good to go? Okay, so maybe just a few opening remarks first of all about why SES-9 is so important for us. And I've got my crib sheet here, and the reason for this is we have 7 satellites under construction at the moment. Some of them very large, and I'm getting older and I just cannot remember the specifics of each one, so I've got my little cheat sheet here. So we're going with SES-9 today. The all-up mass of SES-9, wet mass, is going to be around about 5,721 kilos. The satellite is going to 108.2 degrees east. It's going to be serving our Asian marketplace. It's going to be the largest satellite that SES has in the Asian marketplace. This is why it is so important for us. Really, this satellite is now the first of 7 satellites that we're going to be launching. And that's why we were here 2 years ago. We were saying this was the first commercial launch that we did with SpaceX. Now we're here again. It's a new phase of SES. It's a new phase also with SpaceX. We're excited about that, and we're going to move forward over the next couple of years. And just to give you a feel for that, we will also be launching 2 more satellites, SES-10 and SES-11, both with SpaceX this year. So that's 3 launches with SpaceX this year. So I think it's good for us, it's good for SpaceX, and it's also good for the state of Florida as well. So we want to try and bring you some business as well. And it doesn't end there. It doesn't end there, because the following year we'll be back and we have more launches also with SpaceX. We have 2 more launches with SpaceX, with SES-14 and SES-16. So we have a really significant relationship with SpaceX. And I'm going to talk to you a little bit about how that relationship has developed and how well we've worked together with SpaceX. Just going back to SES-9 for a moment, this satellite is, as I said, it's going to be for Asia, Southeast Asia. We have 7 missions on board the satellite, and basically the usage of the spacecraft is broken into 4 verticals. We have video, so we're going to be developing the video marketplace there. We reckon that we'll be extending our usage by around about 22 million homes in Indonesia and in the Philippines, developing the high-definition marketplace there. We'll also be putting in support for enterprise-type data services, so conventional VSATs, etc. We also have a mobility package on board. Predominantly, this is for maritime services, so we have an Indian Ocean beam, which will be used for the shipping in that area, but also we'll be looking at aero mobility for the regional marketplaces in Asia. And finally, institutional marketplace, government-type services as well. All of these will be supported by SES-9. So this is really a very, very big deal for us. It will be co-located at 108.2, it will be co-located with SES-7, and it will be basically taking over service from NSS-11 as we start to move services across onto the new satellite, which will give us better coverage, higher power, etc., etc. Now going back to the mission just for a moment here, and this is really where I'd like to sort of emphasize the relationship that SES has with SpaceX. We sat with SpaceX and said, guys, how can you improve our mission profile? How can you get us to orbit a little bit quicker? And so we have agreed with SpaceX that we will change the mission from a guidance controlled shutdown of the second stage to what we're calling a minimum residual shutdown of the second stage. To de-technify that, and I'm speaking under Emily's control here. Okay, so say anything, just shout or throw things. Okay, what it really means is quite simple. We're going to burn the motor on the second stage for a few more seconds. That's all it really means. Okay? The big deal about that is that we're going to reduce our time to orbit by about 45 days. Initially, we expected to take about 93 days to get to orbit, but those few more seconds of burn will bring us down to about 45 days. So that being said, we should be in operational service towards the end of May or right at the very beginning of June. So that is a big deal for us. It's a very big deal for our customers as well. They're very excited. They want to get on with this. They want to get the services up and running. They've been waiting a little bit of time for this. But you know, the most important thing for us, the most important thing for the space industry, for SpaceX as well, is the reliability of the vehicle. That's really all that matters. I know we're a little bit late. Okay, fine. We can live with that. We move on. What's most important is that we get the perfect mission. And that's really the basis that we have this relationship on. So we'd like to thank you guys for helping us on that. And we really appreciate the efforts. So wrapping that, the rocket is actually horizontal at the moment. It was vertical when I left. It's horizontal again at the moment. We're looking for launch, as you know, tomorrow around about 20 to 7 in the evening. And at the moment, the only thing that's holding us back is the weather. We don't know what the weather's going to be like. We have a 60% chance at the moment of launching. Predominantly due to clouds, maybe thunderstorms, and also for ground level winds as well. So that's what we're hoping that we're going to be good. Say 60% chance. Thursday looks better. We have 80% chance on Thursday. So with that said, you know, we're here. We're excited. Beginning of a new phase. For SES, as I said, 7 satellites under construction. That's an investment for us of around about $1.7, $1.8 billion. So it's a big deal. It's a really big deal. So this is really the start of the next phase of SES's development. And we're just very excited about this. We want to get this movement going. We want to get the next phase moving on, get this launch out of the way, let's be successful, and go forward from there. Emily, any words you want to add to that? With that, I mean, I can go into all sorts of technical details. I don't know how much you really want to know, but I'm here for a Q&A and happy to try and answer any questions that you may have.
The SES going forward in this phase, do you expect longevity of this satellite as it is produced now to stay basically within the parameters it is going to develop at this point? Or do you see it changing going forward as you launch future satellites?
It's a very, very good question.
Martin, so can you repeat the question because not everybody's...
The question, and let me see if I can paraphrase it correctly. The question is, as we go forward with the design of our spacecraft and whatever, do we see the longevity of the satellite being as it's designed for today, so 15, 16, 18 type years, or is that what we'll be looking for the future? Is that correct? Okay, so the answer is a very interesting one. We can build satellites that will last in orbit 23, 24 years. But think of this. When we design a satellite, first of all, we look towards what the business is going to do. It's all business driven. So we look at the business and we do an analysis on that. It takes us about 6 to 8 months. We then find a vendor to build the satellite. The satellite takes around about 3.5 years to build. Then we have the launch to go through. So from concept, 4 years in, we haven't even launched a satellite yet. The satellite is then designed ostensibly for around about 15 years. So you're looking at a 19-year span here. Now, let's look back 19 years and where we were. You know, and you think, well, hang on, is this going to be meaningful in times to come? So my answer is, and this is where I'm going out a bit on the track here, and it's something more on the innovation side that we're looking at here, is that we believe that our satellites have to be more flexible. We believe they have to have more flexibility on board and more adaptable on board to the demands that will come that we don't even know today, we don't even see today. My view is, it's a personal view, I think the cycle time of the satellites will go down to around about 7 years. And how we will do that is something which we're working on right now. How we will be able to modify our satellites when they're in orbit to have the capability to augment the payloads is something that we're working on right now. So we will launch satellites with the capability to have an interface, an accessible interface, where you can join another payload whilst it's in orbit to give it additional capabilities to basically keep it meaningful in the fast-moving data world. So yeah, it's actually becoming asymptotic. The longevity of the satellite is not the driving factor anymore. It's difficult from a business point of view to say, I'm going to do this over 7 years rather than 20 years, you know, because of the depreciation of the spacecraft. But we believe that the cycle time and the reaction time has to come down. We have to make that thing far more meaningful. We have to keep it really accessible to the type of data services that we see. They're moving so quickly now. As we look towards 4G, 5G, etc. Terabit satellites are there. They'll be there in 2 to 3 years' time. We're going to need to be there too. So I think we're going to see satellites being cycled much faster. Sure.
James in Florida today. You gave us a big number for the value of all 7 of these satellites. I was wondering if you had a number for SES-9 specifically, or are they all about the same?
No.
Also, is this your first electric propulsion vehicle, and how does that sort of change the dynamics?
Okay, so the question is basically what's the price of SES-9, and how does the electrical propulsion, is this our first electrical propulsion satellite, and how does that change the dynamics of our business case? Is that essentially the question? Okay, first of all, I can't tell you the price of SES-9. That's obviously information which we don't give out. It's expensive satellite. It's expensive. From an EP point of view, from an electrical propulsion point of view, keep in mind that SES-9 is not an electric-only propulsion satellite. It's a hybrid satellite. We're also carrying, should we say, conventional propellant on board as well, which will shorten our time to orbit. And that's really, we're carrying around about 2.6 tons of fuel on board as well. So it's quite significant. The EP element, the electrical propulsion element, is only for the circularization of the orbit and the subsequent on-orbit station keeping. But it'll still give us a lifetime in excess of 20 years.
Is the launch profile adjustment, the longer second stage burns save you chemical prop, to get to your orbit, or no impact
Okay.
on the lifespan of the...
It's a good question. So the question was, does this modification to the mission profile give us more chemical propulsion usage, basically, for later in the program? That's another, it's a little bit more complex than that. The chemical propellant that we have on board is only used for orbit raising. It's not used for on-station. So what we're trying to do is optimize the injection of the orbit that we use all of the propellants by the time we actually get to the final altitude. So that's the game that we're trying to work at the moment. And so that's a balancing game. With the discussion that we've had with SpaceX, we hope to raise the orbit from a contractual number of around about 26,000 kilometers. We're trying to raise it to around about 39,000 kilometers. And so we're going slightly super sequence, which means we're slightly above our final altitude, our final required altitude. And this will allow us to be able to reduce the amount of propellants, both electrical, xenon, and also biprop, that we actually use for the final orbit destination. So it's an optimization of the use of fuel and the time that we need to actually use it. That's really what we're looking for. And I said that ends up at around about 45 days improvement. Big deal.
Could you just go through the flight profile, starting from in and to cutoff, how long the first burn and second stage will be, and how long the closed, and how long
Do you
the
have
second
that
stage?
information to hand? Because I don't have it in my crib sheet.
Thanks. And I guess on a related note, obviously SES has not been shy about being first in line for any of the products or services that SpaceX offers, but did you get some confidence after the demonstration of the second stage restart? Was that
Absolutely.
work near you? I mean, or
Absolutely. Okay, so did everybody hear the question? Do you want to repeat the question? It's pretty easy. You repeat it.
Go Irene.
Okay, well, my first question was about the launch profile, and then the second question was about confidence after a demonstration of the second stage restart.
Sorry. I'll leave. You talk about the profile, Emily. And for the second stage restart, sure, it always brings confidence. There's no doubt about that. We also have to turn back to our insurers, and we have to fly. We have to basically imagine that we're flying without insurance, and then when we are confident, we will turn to our insurers and we will show them why we're confident and the reasoning behind that. The second stage demonstration, of course, is huge, and it retires an awful lot of risk. There's no doubt about that. So that was very good, and it was very strong for SES, and it certainly, again, develops the relationship with SpaceX to have that sort of integrity. One thing I would also say is, in adversity, you really see how good a company is. And I think, and I'm not being negative here, I won't spend more time on it, but the recovery after the failure is when you really see. We've had the same situation with ILS and Proton. We've had the same situation with Ariane 5. It's what it is. It's the industry. But when you see that, And when we have our own people embedded in Hawthorne working together with SpaceX, we had access to the data to our US citizens, which was really unprecedented and really gave us that confidence to move forward. It was extraordinary. It really was. So I'm going to hand over Emily for the profile.
Okay, I'll just give you a top-level profile. I think everybody knows that our T0 is at 6:46 p.m. Eastern. I think it's 6:46 and 37 seconds, for those of you who track those sort of things. At about 2 minutes and 30 seconds, we're going to have main engine cutoff for all 9 engines on the first stage shut down. We'll have stage separation a few seconds after that, and then the second stage engine will start at about 2 minutes and 50 seconds. At about 3 minutes and 40 seconds, the fairing will deploy. And then about 9 minutes in, we've got the second stage engine cutting off. And then we begin our post right around 10 minutes and 30 seconds. And it's going to post for about 17 minutes or so. And then we're going to restart that second stage engine at about T plus 27 minutes. We'll shut that engine off at about T plus 28 and looking at deployment at about T plus 32 minutes.
Maybe just to finish the mission from our point of view, we'll have acquisition of the spacecraft around about 22 minutes after separation. Thanks, Emily. No questions?
Excuse me, sir. Looking again from quite a hypothetical standpoint, the progression of the future of space, looking at the Dragon capsule, with its capability of docking at the space station, etc., do you see a time and place where this type of satellite being launched would actually be in a situation like the International Space Station, where a satellite working in place, orbiting in space, would have additions or subtractions to what its capabilities are?
Okay, so let me try and paraphrase that one. It's basically if I make it really short, satellites that we have in orbit today, will we have the capability in the future to be able to modify them whilst they're on orbit, to augment their capabilities, etc. I think the linkage with Dragon is incorrect, and it's really from an altitude point of view. Dragon's flying much, much lower. We're flying at around about 36,000 kilometers for GEO, okay? 8,000 kilometers for our MEO satellites. So it's a big, big difference. So the concept basically of our parking in LEO is really not something which is in line with what we're trying to do. However, as I mentioned before, we're working on a concept together with a vendor where we will have an interface on the satellites that we are launching into geostationary orbit. So it's basically a mechanical interface, electrical interface, comms interface as well. So it will have the capability to add a payload at a later date. The way that we would do that is that we would launch that additional payload with a follow-on satellite. It would be a nominal satellite going to GEO, but on top of that satellite, you would have a rendezvous platform, and you would have the additional payload. So the mission would be that the second satellite would act as a donkey, would take the payload to the already incumbent satellite on orbit, deploy it, plug it in, start off, and then it would move on and execute its nominal mission. That's what we're working on at the moment.
Thank you very much, sir. I'm very glad I asked the question. Thank you for your explanation. It's a great future looking forward.
It's a very exciting concept.
Exciting. Thank you.
Is SES the largest private satellite operator? Yes, we are. We have, and I'm going to say the wrong number now, I know, 53 satellites on orbit. Pause. 53 satellites on orbit. Yeah! I can't even keep up with it, I'm sorry, I'm supposed to be in charge of it. So 53 on orbit, 7 more under construction, and 7 more actually under construction, and we're working on 4 more in concept phase at the moment. So hugely exciting, and an awful lot of business coming down the pipeline. Okay, so the manufacturers of the satellites at the moment, we actually deliberately spread it around. So this satellite that we have today is built by Boeing. We have satellites being built by Orbital Sciences, or Orbital ATK as it is right now, and we have satellites being built by Airbus as well in Europe as well. So we deliberately separate this. We are also obviously in touch with Lockheed Martin, and we also talk with Loral, Space Systems Loral as well. And so we have a relationship with all of our major vendors. And we deliberately try and break it up. You know, because A, they have different capabilities. Sometimes their designs are more precisely focused on the type of mission that we're looking for. But also, it's also good to ensure that if there's a problem on a satellite, it doesn't become a generic problem. If you bought 10 exactly built to print, and you have a generic problem that can run right through in 10. Once you're in orbit, you have some limited capability on what you can do about that. So we deliberately break up with the vendors and break up the satellite types.
Has SpaceX tried to, we're talking SpaceX all about buying a reused rocket?
Okay, have we been talking to SpaceX about using or buying a reused rocket? Yeah. Yes, I have. Yes, I have. We've talked to Elon about this, we've talked to Gwyn about this. We actually went up and saw the vehicle that was brought back. I mean, very, very impressive indeed. The answer is SES would have no problem in flying a reused first stage. Absolutely no problem. If it's flight worthy, we're happy with that, that's not an issue. Basically, it'll be from a technical capability point of view and from a financial price point of view as well. If that all fits into our contract, we have no problem with that. But I did throw out a challenge to SpaceX that we would be the first satellite operator that would use the same rocket twice to get to geo orbit. And we discussed that with our investors, and they really liked that, and that's something which I would really like to do. So there's a challenge for you. Let's bring it back, put another satellite on it, and we use it again.
Any ballpark figure of what you think, how much of a reduction in launch cost would be?
Oh yeah, I can give you a number.
Okay.
But it's not the number which is agreed with my friends. No. I honestly can't do that.
No.
But I'll give you an anecdote. When we brought this up with Gwyn, she said it should be more expensive because it was flight proven.
So on that note, how much of a reduction did you get in your insurance after the demonstration of this stage restart?
Our insurance is more complex than that. It's not focused specifically on this vehicle, on this particular vehicle. We are actually at one time insuring six launches. So it's actually it's spread across all six. The risk is basically an aggregate risk across all six. So it's really not material.
Martin, I have a quick question.
Sure.
What do you think, what has insurance companies done behind such an insurance? What have the insurers, the insurance industry mentioned about?
Okay, what have the insurers said about us flying a second, right, or reused rocket? Just to call it a second rocket. Yeah, light used.
Flight proven.
One little lady owner only drove it on Sundays. Yeah, right. The insurers are very interesting people. They look to us, they look to SES, and they say, guys, do you believe in this or not? And they really look you in the eyes. And we have to have a belief. Once we are capable of having that belief, of being comfortable with this, and putting an investment which can be $500 million on top of this, then they'll say, okay, you're prepared to do it, we'll go with you. So what we have to do is, obviously we have to work through qualification, we have to work through all the various different flight verification, testing, etc. Once we get through that, I don't see any reason whatsoever why we wouldn't fly. Absolutely not. I'm sorry. How far down the road? Just answer that one. How far down the road? I don't know what else. I didn't that. What are you going to tell us for?
What's off?
Okay, we're talk.
Sorry.
Hey, Steve.
I'll touch on that. Do you think there needs to be a demonstration flight for the new project with some community? And also have a customer.
Okay. So how many demonstration flights in the reusable first stage? Well, actually, I would say we don't need any. I don't think we need any. I mean, we've had the proof that we can fly the thing back and land it. I think the analysis of the status of that vehicle, what if any rectification work is necessary to bring it back to being fully flight worthy, that's something we need to understand. And that's obviously something which SpaceX is working hard on right now. But if we can get through that, we can get through the verification testing and such like, will there be another couple of tests? I believe they'll come back, but then I think we'd be quite happy to fly. I don't think that's not a showstopper. Do you have a follow-up question?
Yeah, on this mission, clear up the role of the chemical and electrical propulsion. So you mentioned the chemical is only for whatever reason. Is it going to be directed to GEO? To the propulsion supply and or the electrical can do it similarly?
Correct. Okay, Steve. So basically, it's the usage of the hybrid propellant system when we're using the chemical system and how much we're using the electrical system and what's used. Now, the majority of the heavy lifting, if you like, is being done by the chemical propulsion. We are not using chemical propulsion on orbit at all. So if we can drive it to depletion by the time we get to the final altitude, then that's fine. That's perfect. Because we don't want to carry around any mass. So it's basically just fire some latch valves, you shut it off, and then for the rest of its lifetime, you're just moving mass around. So if you can actually use all your chemical propulsion, get to altitude perfectly, that's fine. So what we actually do is, in our mission planning, is we make sure that we exhaust the chemical propellant just before we get to our final altitude, and we do the final tuning with the electrical propulsion. So that is the optimization of the mass budget for the spacecraft when it's actually on orbit.
And one more on that, how many orbitals and planes are there?
Let's go back to the number of firings. I think we'll have to take a look at that. We'll have to probably modify that when we see exactly what injection we get after the MRS, when the minimum residual shutdown. There'll probably be a slight change on that thing, so I can't give you the specific number. What we can do is we can come back to you after we get the injection and we can tell you exactly what we're going to give it. So. Deployment is nominally, first of all, let me think, we have a deployment of the solar arrays. Normally, I would think 2 days, probably from launch, we're probably looking at about 30 hours. Oh, that's not good. But not, if I remember rightly on this mission, it's not a full deployment, it's partial deployment, then full deployment.
You haven't said anything about your ground station on orbit support. Describe overall.
Okay. Okay, so the ground station for on-orbit support. We have many different ground stations. We have 38 teleports on a worldwide basis that we use for this. Not only for this satellite, but for the entire fleet that we have. These are all networked together. All of the satellite control facility is concentrated both in Luxembourg, where our headquarters are, and also in Princeton in the United States. So we have two satellite operations centers there. They are entirely redundant. If one fails, the other one can take over the control of the entire fleet. We also have a station in Gibraltar where we normally fly around about 8 satellites. That's for regulatory reasons, and also, if you like, it's our ace in the hole if we have a total failure of the other two as well. All of these stations are networked together. Any of these stations can take control of any of the satellites at any time. Now that's from the TT&C point of view, the control of the spacecraft. On top of that, of course, you have all the traffic carrying as well. Now, obviously, a lot of the traffic is being sourced from VSAT networks, for example, from broadcasters, from their own facilities, etc. So it's kind of a combination. We don't nominally support all of the traffic which is being transmitted on the spacecraft. We will help if we are needed to, and we will offer that provision to a broadcaster, for example, if he doesn't have the capability to be able to transmit to the satellite. But by and large, the traffic side of things we hand off to our customers. Yeah?
I have a, go ahead.
I had a question for Emily.
I did too.
Oh no! Well, it's related to the, I'm sure we all have the same questions, so maybe you can take this even though you did say you want to speak about SES, which is the energy of the first stage and how that compares with the rocket, say, that flew in December, and why you were able to get back to land on that versus the speed that would be used for that SES-9 launch. Just to give us some comparison about why this is an ocean landing and a icy one at that versus the landing in December.
Yeah, just for your background information, I have kind of one point of comparison. So for both missions, the stages are separated about 100 kilometers. For ORCOM, I think the first stage is moving away from the launch pad at about 5,000 kilometers per hour at separation. For SES-9, it will be 8,000 to 9,000 kilometers per hour. to give you a sense of the higher pressures that heat the stage will burn and the larger two emissions are higher.
Thanks. And where is the spaceship going to be?
It's going to be about 400 miles offshore, and it's our, of course, ISO level drone ship.
Off the...
I'm not sure exactly where offshore.
Where's it leaving from?
Left out of the port.
It's right there.
Yes, it's right behind you. Yeah, it's about 400 miles out.
Thanks.
Yeah, this is just for you too. It's just I'm sorry. It's the same question I already asked, but is it the weight of a satellite? What is it that's changing? It's just the weight, and you're not burning any longer on the first stage, right? And it's not lofting or something under projection. It's just the weight of the space.
It's the energy.
It's just the weight.
It's just the energy. Done it? We go, oh no!
Any plans on removing dead cells?
Any plans on doing that? Well, okay, let me tell you about the policy of what we do here. This is quite interesting one. I don't know how au fait you are with what we do with the satellites at the end of life. Normally, what we do now is, and it's actually required now by the International Telecommunications Union, you use the last part of your propellant on board your spacecraft to raise the orbit. You don't bring it back, you actually push it further out. So you push it out by around about another 300 kilometers. And then you passivate it. If you remember some time ago, there was a very old satellite where one of the fuel tanks ruptured and caused a lot of debris. So what we actually do is when we get to the 300 kilometer mark, we vent all the tanks, we switch off all of the batteries and shut the thing down. So it's actually dead mass. And it's in an orbit which will oscillate backwards and forwards between mass concentrations for around about 100,000 years. But it's not a dangerous, it's a totally inert object. There's no active component left operating on board. But we have no capability to bring the spacecraft back from GEO. We don't have the energy to be able to do that. But just to give you an idea of what's going on up there, you probably know that we also have a medium Earth orbit system called O3b, which operates around about 8,000 kilometers. There was, we also work very closely together with JSPON, formerly known as NORAD, and they tell us if there are going to be any close encounters. And we had a close encounter with an Ariane 1 upper stage, and that was launched back in the 1970s. And it came a few kilometers past us. We knew where it was, there was no danger in it whatsoever, but there's a lot of stuff up there still. A lot of stuff, and it's still in orbit. It's slowly decaying, but it's going to go for a long, long time.
When do you expect to deliver SES-10 and 11 to the
They're both being built by Airbus. They're coming out of Toulouse, and in principle, and I look at Emily now, gets her manifest cracking. We will be shipping those spacecraft in here in September and then October. September, October. Normally a month before. So we do all the prep on that side and whatever. So that should be it. Yeah.
To this current date of February 2016, can you tell me, from SES's inception of the very first satellite, how many years have evolved to the current date of the introduction of the satellite?
Okay, so the first satellite we launched back in 1988, relatively small. It was actually built in East Windsor, New Jersey. 16 channels. Made us a bucket full of cash. Very good satellite, very, very good. Astro 1A. So 1988. So that was. So we started to build that in 1985, 1986. So that's really the longevity from the SES's point of view. So up until this satellite, construction started around about 4 years ago. So back in 2012, or that sort of thing. And we've gone, as you can see, from 16 channels basically, running at around about 50 dBW to today's satellite to be launched, which has the equivalent number of 81 transponders on board, from 16 to 81. So 5 times the capability, 5 times the capacity. That gives you an idea over what, 20, 30 years, just under 30 years.
So lot of things to benefit mankind.
Well, I don't know, some of the television was pretty bad. I wouldn't go that far. It's a lovely thought, and I'll stick with it. I'll take it, but truth might be a little. Oh yeah. Guys, we okay? Any other questions? I'm around anyway, so if you come up with anything I can try and help you with, then let's do that.
Thank you.
Thank you very much, guys. Cheers.
Good luck.
Thank you.